بسم الله الرحمن الرحيم والصلاة والسلام على نبينا محمد وعلى آله وصحبه أجمعين. Okay, so this is the second chapter of the course Introduction to AI and Data Science, and this chapter will be Introduction to Python for Data Science, and we start with the first lecture, so starting with the basic syntax and the most important concepts of the Python programming language. So what is Python? So Python is an interpreted language which also supports object-oriented programming like C++ and Java. It offers high-level programming scripting language with dynamic semantics. So it's not a typed language, although recently the newest version also support to enforce a type for particular variables. But initially Python doesn't support type, so the type is dynamic. And it was developed late in the 1980s by Rossum. So what characterized Python programming language is almost one of the simplest programming languages, much more simpler than Java or C++ or other programming languages. Also, it has a very, very large variety of libraries and packages. And this is the language number one, especially for data science and artificial intelligence, considering the easiness of usage and also the abundance of the libraries and the packages available for machine learning, artificial intelligence, and data science in general. And it's basically used by developers and engineers because it increased productivity and also doesn't have the issues of C++. I don't know if you have already worked with C language. It has always issues about memory, like segmentation fault when you have issues with the memory. So another benefit of Python is also it's a multi-purpose language. It's the number one, as already mentioned, for data science, and it's also used in web development. Now, for example, there are several frameworks that were developed around Python as a backend for server-side websites, like, for example, Django, Flask. These are different frameworks and libraries that are developed in Python for the web development. It's used for system programming. In pretty much any kind of field, you will find the appropriate Python package to work with. So I've been using a lot C and C++ and then Java, and since I started to work with Python, I find that it offers almost anything that you need. So I didn't have to go back to these programming languages. Of course, C is a little bit different because when you go for embedded system programming, so basically you need to promote real-time and responsiveness. So this is the most beneficial advantage of C and C++ is the speed. But of course, the newer version of Python are improving in terms of performance, so the gap is closing. But C remains always the most efficient and the highest speed programming language because it works directly at the low level. So let's look about the Python popularity, and these are some statistics by Coding Nomad of the most in-demand programming languages in 2024 based on the LinkedIn job posting in the United States. And you can see that Python comes at the first place, and then Java, then we have C++, then we have JavaScript. But of course, this depends also on JavaScript is number one in web development. So almost any kind of web development, it will use JavaScript either in the front end and also in the back end, like with Node.js. C, C#, .NET, TypeScript, which is a variation or high-level variation of JavaScript, Android, and Perl. So this is also another ranking of programming languages in 2022 and 2021, and you can see consecutively. So there is kind of a consensus that Python is the most important and the highest demanded programming language everywhere. And then C. Now, for the second place, sometimes you can find C, sometimes you can find Java, sometimes you can find JavaScript. Okay, also depends on which type of applications. But as you already observed, and even here, we can see the trend from 2002 to 2022, and we can see an increasing trend of Python. So if you see Python, for example, back in the early 2000, it was not as popular as now. Maybe Java was more popular. I remember at that time, Java was actually boosting with Java Spring and different type of framework. But now, if you can see now, starting from 2018, maybe when deep learning becomes more and more popular, okay, so we start to have a big jump and rise of Python over other programming languages. And this is also a historical ranking from 1987 to 2012. So you can see now, C was the most popular, which is not surprising. And then we have Prolog, Lisp. These are the very old type of languages, okay, back in the 90s. And then with the evolution, you can see now Python start to drop from 28 to 12, start to be ranked in 1997, and now it becomes the first language. And there are several big tech applications that are using Python, like Instagram, Facebook, Google, and several others. So first of all, before starting to work with Python, you need to install it. And there are different ways, depending on your operating system, and also depending on the distribution that you want to use to install Python, but it's pretty much straightforward and easy. So you have two possible options, basically, to install Python. You can install it from the official Python installation, and this works on Windows, Mac, or Linux operating system. Basically, you need to download it directly from python.org. And it's just step-by-step installation that you need to follow until it is installed. And also you need to configure your path system to Python. So you need to indicate where Python is located. Another option is to use Anaconda distribution, which is also a framework which is recommended for data scientists to use Anaconda. It's another layer on top of Python that provides a little bit better environment management using the Conda environment management tool. It will install Python, it will install Conda, and also additional libraries will be installed by default. Like, for example, NumPy, Pandas, and SciPy, so they will be installed by default. This is why it is recommended for data scientists. If you install Python by itself, you may need to install these libraries manually. And the package management in Python is quite smoother and easier than in Java. But you know, usually in Java, you need to import jar files and so on. Now, or if you use some framework like Ant, or there are other package management tools. I don't remember all of them, although I've used them before. But basically, you can use Conda package manager or pip install package manager, the default package manager of Python, and you can install any library into your environment. And the good thing with Python is that you can define several virtual environments. Because if you install Python in your system, you might have different projects, and this project will have different type of libraries. And sometimes if you install everything into the physical machine or the main environment, you can have conflict between different libraries. So in order not to have any conflicts in the installation, we can create virtual environment. For example, the first project, you will install it in one virtual environment. It will be completely isolated. Okay, it's like a container that will contain all the libraries. And you can do this either with Python, direct installation, pip, or you can do it also with Anaconda, creating virtual environment. This is a very good practice to isolate the environment where you're going to work. Okay, so in this case, you won't have any issues between conflicting libraries. And also, if you want to port your environment into another system, you can collect all the requirements, which are in different libraries, and install them into another environment. Yes?
For this course, which one do you prefer without?
I'm not going to give a preference. You can use both. I prefer that you use both, so you get used to Python virtual environments or Anaconda also virtual environment. But basically, it's only the syntax. You know, from usage perspective, only the syntax might differ slightly, but at the end, you're going to have the same benefits. Okay. So, and both, they are compatible with Windows, Mac, and Linux. So this is the page, the installation page on the Anaconda. You just need to install it. So you install the Anaconda software, and then it will provide you a graphical interface from where you can manage your packages. So you can manage your packages through the graphical interface Anaconda, or you can manage them through the terminal. Both are possible. Yes?
Do we start downloading them here, or it's only for our use?
I couldn't understand.
Do we start downloading them here?
No. I'm going to provide you the concept, then I will give you some assignments, homework to do. You can install and also start programming with Python. But in most of the time, although it's good to go into them, most of the time we're going to use Google Colab, which already contain pre-installed environment. But in any case, everyone should work with an integrated development environment, like for example, VS Code or PyCharm. I'm going to introduce you to VS Code. But most of the illustration, I'm gonna do them on Google Colab, so I can share with you the notebooks easily.
So,
Yeah.
Can we download game on the lab?
No, don't waste your time because I'm going to explain and you will not get the concept. Now, in the lecture, we start understand the concept, and then I will give you notebooks, I will give you everything later on to do hands-on. You know, without doing hands-on at home every day, it's going to be very difficult to grasp the concept. You can understand. If you don't practice, everything is going to be practicing. Okay? So this is very important. So check existing Python installation. First, if you want to install, check whether you have already a Python installed on your machine or not. And you can do this using Python -- version or Python 3 if you have Python 3. Okay, so now the default version is Python 3. Initially we have Python 2, but now we are at Python 3.12, I think. So it's still advanced. And verify if Python is already installed. And then depending on your operating system, there are a set of tools to use in the terminal to install. So in Linux, if you are familiar with Linux, usually we use sudo apt-get update in order to update the current packages. Okay, and if you want to install Python, you will do it sudo apt-get install Python 3. So this will install Python locally. And when you install Python, you need the package manager. Okay, and for this, you're going to install pip. So pip, this will allow you to install any library. You want to install pandas, you want to install NumPy, you want to install matplotlib, any kind of library, you need to have a package manager, which is pip. If you install Anaconda, you can install it, so you will have Conda as a package manager. Instead of making pip install NumPy, you will do Conda install NumPy. And even if you work in a Conda environment, pip install is going also to install it in the Conda environment. You can have some, there are several YouTube videos about the virtual environments, about Python, that you can watch and also apply. But these are the different ways on how you can do them. So to install the pip, the package manager, sudo apt-get install Python 3-pip. And this will allow you to install packages with Python 3. So in macOS, it's slightly different. First of all, so instead of we don't have apt install in macOS, we have the brew package installer. So this is the way on how to install the homebrew on your Mac. You just need to download this install.sh and execute it. And then once it's installed, you will do brew install Python. It's going to install the latest version of Python into your Mac operating system. On Windows, so there is the Windows subsystem for Linux, WSL. If you install it and enable it, so you'll use exactly the same Linux commands to install on Ubuntu on Windows operating system. So for Python integrated development environment, which one to use? Okay, it's up to you. Personally, I prefer VS Code. It's multilingual, works pretty much smooth for any kind of programming languages, especially if you have project that will involve web development or data science or Python or Java. I don't like it much for Java. I still prefer to use NetBeans, although it works. But for other programming languages, there are a lot of extensions that could be helpful. You can customize your integrated development environment different ways. I think this is also possible for other ones, like PyCharm is only for Python, like NetBeans for Java. And I do recommend VS Code. This is, like, based on my knowledge, the most recommended and preferred integrated development environment used by programmers. So for development environment, when you install Python, you will have an integrated development environment through a command line that you can use, okay? And this is only suitable if you have very small scale project. It's basically, we don't use it much. This is like an interpreted and interactive terminal. You type command that is going to execute and show you the script in real time. The other options is to use PyCharm. Okay, it has a community edition which is free and also a professional edition. And this development environment is customized for Python development with advanced debugging, code analysis, and refactoring tools. And the third option is Visual Studio Code, which is a generic, free, open source, and highly customizable development environment. It has full Python support with several extensions. These are the plugins or the extensions that you can install to customize it for your Python project. Okay, and it's ideal for various development tasks. For interactive development, we usually use notebooks. Okay, so notebooks allows you to write a code and then execute it and see the outcome. And the most popular notebooks is Jupyter Notebooks, which you can find locally. You can install it locally. You can do pip install notebook. In VS Code, it's also available, so you can use VS Code notebooks with VS Code. Or we can use it online using Google Colab, which is this option. So this is a Google Colab. I'm going to share with you this notebook. And usually notebooks allows you to write to different type of cells. A text cell, if you want to write, for example, some text, introduction to Python. And also it allows you to write a code text. So for example, here we can make print hello world. Of course, it's going to connect to a machine on Google Colab. After it connects, it's going to execute. And now Google have integrated AI generated code. So of course, I don't recommend, especially if you are learning, to use it, but you can use it to check yourself. ChatGPT can write all the code for you. But now since you are learning, you need to make the effort to write the code on your own. Okay, because it's a little bit tricky to move from Java, which is a highly customizable, the syntax is very rigid in Java, and this is a scripting language. Okay, so usually scripting languages are more difficult to memorize. Although Python is very simple, but it's really important to practice as much as you can so you get the habits of the Python programming language. And you can see we don't use semicolon. Okay, it's an annotation language. I'm going to provide you the basic concepts and syntax of Python. Yeah.
Having knowledge in Java can make me do Python easily.
I mean, the programming language doesn't make any sense. The most important thing is that you have the concepts of programming. And then the programming language is any, if you can, it's a language. It's like you learn French or you learn English or you learn German, it's just a language for communication. But the most important thing is the algorithmic part, is the way on how to design an algorithm. But the syntax, I don't even require you to memorize the syntax. I will allow you to use cheat sheets. Okay, so if you forget the syntax, I don't even memorize all the syntax of Python. Okay, because the syntax is very rich. So I want you just to have the concept of programming, what syntax to use in which case. That's it. Okay.
Is there going to be a lot of programming in this course, for example, or just a little bit?
Yes, so Python is a big chunk. It's at least 30% of this course.
30%?
Yeah. So this is your introductory course to Python, and also we will apply it to data science. So you will get all the essence of Python, okay, and how to apply it to data science. Okay, so this is Google Colab. I'm going to share with you so you can execute the cells and make trials and errors, check if you change the syntax and so on. This is how you can learn. But now I'm going to provide you the most important concepts about Python. So Python is very rich with libraries. And this is one of the reasons why we use it in this course. So you have the Python module, the the main module, and then you can install other libraries. For example, for data structures, we have NumPy and Pandas. You will be introduced to both. Okay, so NumPy, we use it, for example, in high intensive computing, like for example for machine learning, training machine learning is basically the data structure, and Pandas for mostly analytics, data analytics. You're going to load, for example, a database table or a CSV file into a Panda frame, and then you can do different type of statistics or query on your data. So Matplotlib and Seaborn are for visualization. If you want to draw different type of charts, like histograms or box plots or any kind of scatter plots, we can use Matplotlib and Seaborn. And Seaborn basically is based on Matplotlib, is kind of a wrapper layer on Matplotlib. For scientific computing, we have scikit-learn, which implements several machine learning algorithms. We have SciPy for scientific computing, and OpenCV for computer vision applications. So for storage and databases, there is SQL Alchemy, MongoDB, SQLite, MySQL, and so many others. Even in Oracle or any kind of database, you will find an SDK or an API to work with. And for deep learning, there are also other frameworks like PyTorch, TensorFlow. These are the two most popular frameworks for developing deep learning application based on neural networks. So TensorFlow was made by Google, and PyTorch was developed by Meta, which is known also as a Facebook. So in order to work with Python, you have a package structure. Okay? So what is the package structure? Usually we're going to create a Python package, and inside the Python package we will create Python module. So a module basically is a Py file, is a Python file. And this is an example of a Python file where you define the Python syntax. Okay? So a Python module is just a single file containing a Python code. We call it a module. It has a .py extension, like for example example.py. So here I have hello.py. This is the content. And you can define functions, class. You know, it's like you have a Java file and you can do anything you want. You can define classes, methods, and execute them. And this file also can be imported. So you can create a library, a module, that you can import it into another file. And this is a sample code. Okay, so here we define a function that is called greet. And you can see we have indentation. This is one of the characteristics of the Python programming language. And you print hello world. And then, so of course, this is, for example, in example.py, and then we can import example and run example.greet. So it will execute the code. So what is a package? So it's the folder that contains all the Python modules. We call it a package. We create a Python package. And it is characterized by a special file that is called --init_.py. So this is what actually characterizes. If you don't put this file, it cannot be executed as a package. And the package is something that you can also install. Okay, you can make pip install. And of course, we need to have setup.py here to create a setup for the package. And this is actually required to recognize all the files that exist into a certain package or into a certain directory. And this will allow you also to import the package in other modules or in other Python files. So this is the very simplistic structure of a Python package. It contains, so the package itself as a folder, different modules, and also the init.py file. So let me apply this. Now, for example, when we work with VS Code, so you can create a workspace. I have created a workspace into the VS Code. So how did I create it? I created just a folder over here, and then I open this folder, add folder to the workspace, and I can select this folder to create the workspace. And inside the workspace, this is where you are going to create all your packages, Python packages. So in order to create a Python package, I can create a folder here, okay, CS316 package. I can create it from here, or also I can create it, so it will appear here. You can also create a package. Okay, let me create another one, CS316, okay, I made 12. Okay, so it will be also created over here. Let me change and increase the size. And inside the package, I can create a module. Okay, so I can do .init.py. It's an empty file. Don't put anything. This is just to make sure that you have a package. You create a package, and then let me create hello.py. And this is the Python package. I can define a variable. Okay, for example, s equal hello world, and I can do print s. So now I created a module. It's already created here. Okay, and they can execute. So in VS Code, I can go here, create a terminal. I have a virtual environment here. Okay, so I used Conda. Now we can find CS316 package, and this is the code. I can do Python hello.py, and it executes the script. Very simple. Okay, so we created the package, we created the module, and then put some code, execute the code. This is just the pipeline. In Python, there are different types of libraries. There are libraries that are standard. They come with the default installation of Python. Like, for example, there are libraries that deals with the operating system, allows you to create files, create folders, remove files, remove folders, and do anything on the operating system itself. Just a moment. So we have also sys, okay, for system programming. We have datetime, for example, to create a date, certain format, JSON for formatting JSON string. And we have other types of packages or libraries that are called third party. They are developed by other developers. You can develop a package and also export it to the PyPI, okay, repository, and everybody can actually use it and download it. There is a simple way on how you can create your own package and then install it. So this is what we call them third-party packages, and they are installed using the pip, the package manager. Okay, pip install and the name of the package. For example, NumPy request, for example, for REST APIs or pandas, we can use pip install and the name of the package. It will install it from the PyPI repository. Yes?
I was just asking about the vector. You said you should install it inside the Python. It doesn't come as a default.
Which one?
The pip.
Yeah, you have already mentioned the instruction to install the pip, which is the package manager. Yes, Python 3-pip. You need to install it on your system to be.
You can have other libraries.
You can have other libraries into your system. Exactly. Okay, and this is a sample code. So here we import the library. Okay, this is the standard library that we import. And also when you import the library, you have the option to rename it. For example, import pandas as PD. So instead of writing pandas dot the name of the method, you can use PD dot the name of the method. So you can create acronyms. And PD, this is like the standard acronym for pandas. NumPy, we call it MP. And there are known acronyms for matplotlib, is called PLT. So there are known acronyms for, but you can give it any name if you want. And we execute the code, so we can define a main function also. And then this is the entry point of the function. Okay, so this is a method. You can call it anything. Okay, but the entry point is like the main function. You know, system.out. The public static void main. You know, it's equivalent to this syntax. This is like the entry point of the Python script. Although you don't need to define a main function to run a Python script because it's a scripting language. It will run instruction by instruction. It's an interpreted language, not a compiled language like in Java. Java usually you need to compile and then you execute. And this is why you will not discover any compilation error. It will execute, and when there is any syntax error, it's going to stop saying, oh, you have a syntax error in this line. You fix it, and maybe if you have another error, it will come afterwards, okay, depending on the order of execution. So this is a summary of the packages. So you can think about a package as like a desk, and you have several trousers where you're going to organize your modules. Okay, you have a package. It has init.py file to distinguish it from the classical directory, and you can define different modules inside your package. No, init.py is actually used to tell the package manager that this refers to a package. Okay, so in order to create a package, usually we need to have a special file called setup.py. So setup.py is going to create what? Is going to convert the Python script into a binary code that will be executed. If you don't put the init.py, it's not going to consider that this folder is a package. It will consider like it's a standard folder, doesn't make part of the Python project. And this is why we need it. Whenever you, for example, you define, I want to define, for example, here, inside this package, I want to define another folder where because I want to organize. Imagine that you have tens of Python files. You don't want to put them in the same directory. For example, here I'm going to call it mylibs. So, and let's assume I will put other files inside this directory. So, in the way that I've done it, app.py is not going to be considered as part of the Python package until I'm going to create an init.py file inside that folder. Okay, so it's in this case is going to be considered as part of the Python package. Yes?
Is there any situation that we will not put init in this package so that it will not be considered a package?
No. It's one of the requirements. This is how Python package was built, is to use this special init.py file in order to characterize the package from non-packaged folders. Yes?
What did you put inside that init file?
Basically, it's empty. Okay. Okay. Now, let's take a walk through the basic syntax of Python. So as already introduced, Python has very specific features. The indentation. So usually, now in Java, for example, when you want to go from one block to another, you're going to use the curly brackets, right? There is no curly brackets in Python, but we use indentation to define a new block. For example, here, I define the signature of the method, and then in order to define the next block inside the method to tell I'm not going now into the main thread, but I'm in so another block, not in the main block. Okay, so we're going to put a certain number of space, which is a tab. Okay, and this is why you cannot have a messy code in Python. Your code will be forcibly well organized. Okay, because of this indentation requirement, and this is very nice, a very nice feature in Python. Okay, so this is used to define code blocks. So this is a def. If you define an if statement, if you define a for loop, okay, you need to define a tab in order to consider a new block, okay, for that particular instruction. It has a minimal syntax, okay, doesn't require semicolons or curly braces. And readability, it's pretty much easy, clear, and human readable code. Of course, it has other conventions for the definition of the method names. Now, you remember in Java you use camel case, okay, for defining the name of the function. Usually here, most of the letters are lowercase, and they are separated by a dash. Yeah. So the indentation, as already mentioned, so this is an example of an if statement. We don't use the braces, okay, like in this example. Also, if you want to define comments, we use the hash symbol to write comments. So Python ignore anything after the hash. This is just something for readability. It's not going to be interpreted. And you can put them just before the instruction or at the same line of the instruction. Yes.
I have multi-line comments.
Multi-line comments.
Yes. So
Yeah, there are ways we use.
In Java, there is like
Yeah, there are ticks. Yeah, but we can use them for multi-line comments, and it's case sensitive, like in any programming language. So this variable basically is the same. Okay, my variable will change. Python is case sensitive, meaning that variable like my variable and this one will be completely different. So for data types, there are basic data types in Python, like in any programming language, and there are 4 data types: integer, float, string, and boolean. And you can see here, we don't use any typing. Okay, so x equal to 10, x will have a dynamic typing based on the assigned value. Okay, same thing for y, it will be assigned to a float, name will be assigned to a string type, and is valid will be assigned to a boolean. These are the standard types, okay, built-in types, what you call built-in types, that comes with Python installation. And integer, they refer to whole numbers, can be positive or negative without decimals. Float, they are decimal numbers used for higher precision calculation, can be also positive or negative. A string is just a sequence of characters enclosed in a single or double quote. So we can use double quote like this or a single quote. Both of them, they define a string. And the Boolean variables, usually true and false with capital letter. If you write them not capitalized, they're not going to be considered as Boolean values. And you have also non-basic Python data types. The 4 that I've already introduced, they are the basic data types. And this table contains non-basic data types. Like, for example, you have list, tuple, and set. You have already get introduced to data structure. What is a list? What is a set? What is a tuple? Okay. So list is orderable, mutable collection of items. A tuple is immutable. You cannot change it. Huh? Okay. Set is an ordered collection of unique items, and we define dictionary, which has like a JSON-like. Okay, it's a dictionary. It has key and value pairs. We define records. Keys are unique, and the value are accessed with the keys. We can define also complex numbers. They are already defined in Python. You can write z equal 3 plus 4g. And g, it's a special character that refers to the representation of the imaginary part of a complex number. Byte, so it's a sequence of bytes. It's used for binary data, which is immutable. And you have a byte array. It's an array of bytes. It's a mutable sequence of bytes. And also you can assign a value to known. So especially if you want to free a value from the memory, it's not going to allocate any space in the memory. It's a known type. Only one instance known exists. And you can use also the type method in order to infer the type of a particular variable. So now we have defined this variable x, y, name, and is valid. So if I print here, type x is going to return output class int. This means that this variable is of type int. And now this variable is of type float. The name variable is of type str, which refers to string. And this variable is of type bool, which refers to boolean. So you can use type to tell which one. And this is similar to instance of in Java. Okay, already made with instance of. And I will provide you today a notebook. It has all different type of the instructions, basic instructions I present today. So you can play with these instructions and check them. So let me stop here.